All right. All right. Welcome to my talk with 3 refactoring questions. Level up your React skills instantly. My name is Patrick Jurek. I'm actually originally born and raised in Germany, but I've been living in Canada for about 10 years now. Um, I currently live in Regina, Saskatchewan, and I work as a full stack developer for Outpost Health. We are a patient centric digital health platform that currently focuses on emerging markets such as Nigeria, the Philippines, and other countries in Africa. I've been working as a software developer for coming up to about a decade. I worked with government entities in the digital identity and health space, worked for some larger private companies as well as startups. But around the last couple of years, I've really been focusing on consulting and startups. And during that time, I also started focusing more from a technology perspective, and I kind of you'll find me kind of working with React and .NET applications nowadays the most. If you don't find me working away on React or .NET, you're probably gonna find me dropping into Verdansk, playing some Call of Duty, or traveling. But obviously, those ratios aren't all that accurate currently because there ain't a lot of traveling happening right now. So the goal of this presentation here is that I want to share some neat methods on how to identify when to refactor and when to refactor. And to do that, I want to plant a couple of thoughts in your mind that are constantly in your head for the rest of your development life that will trigger you to constantly refactor or make refactoring part of your process as a developer. Excuse me. Well, so maybe asking yourself, are you talking about solid? And yes and no. So solid are the five principles: single responsibility principle, OpenClose principle, list of substitution principle, interface segregation principle, and the dependency inversion principle. Can't even say that all with one breath. But solid is just part of it, and there's so many more principles, and they're all great. But one of the issues that I always had with those is that there are so many principles, and I made it my mission almost to figure out, isn't there like a way that we can maybe just have 2 or 3 questions that we can ask ourselves that encapsulate all of those principles. So I don't have to think about every single principle and apply it. It should just kind of come to me based on those 3 questions. To make sure that we're all on the same page though and kind of starting from the same level, I think we should actually review Solid. And reviewing Solid, how it applies to React, and look at some common use cases. So let's jump right in. So let's take a look at the single responsibility principle. The easiest ways to summarize this one is that reasons to change, we look at a component and want to see what are the reasons for this component to change. Let's say if you have a long component, you have some logic in there, and you have some UI there, well, you might think to yourself, if you have to update how the data is being loaded, that's a reason to change. If you want to update how the list that you render looks like, that's a reason to change. So you kind of encounter this a lot with presentation component versus container, or I guess now components versus hook. So often when you split your component into components and hooks, you're most likely pretty close to following the single responsibility principle. If you want to look at this here in action, here we have a component, a types list component that has on top the logic and how we load the data, as well as rendering the data on the bottom. We split those out into a hook and into the component, and we follow the single responsibility principle. The next one is the OpenClose principle. a good definition for this one is that software entities should be open for extension but closed for modifications. And there's actually tons and tons of ways to do this in React. React just lends itself for composition. So in this example, I created a quick little favorite Pokemon list component. It handles how it gets Pokemons or your favorite Pokemons, as well as a remove functionality, and then renders that within a unsorted list. Now I can use this component anywhere, and I decide as the user of this component how I want to render the list items without ever having to change the favorite Pokemon list component itself. The next one is the list cost substitution principle. Now, this one is a doozy. The one explanation I always hear is if it looks like a duck and quacks like a duck, but it needs batteries, you probably have the wrong abstraction. And I think this one is meant well, but without actually understanding the list cost substitution principle, I always kind of struggled with that sentence. Like, I was like, okay, and how do I use that while I'm coding? Because I don't want to have to sit down and think about something just to refactor. It should just come to me. So I figured, you know what? Let's read the actual definition. Substitutability is a principle in object-oriented programming, stating that in a computer program, if S is a subtype of T, I'll just stop there. All right. I think we just got to look at a couple of examples. All right. So the most common example you will find, probably when talking about the Liskov substitution principle, is something like this. You have a class, and you extend the class, or it could be a class and you create a couple of abstracts of it. And here we have a method called getCatchHere. And it's reliant on the fact that catchDate implements a function called getFullYear. We have that with a JavaScript date object. So during our initialization here, we say let Pokemon equals new Pokemon with a date. This will work fine. But when we create this water Pokemon and we initialize it with a string instead of a date. But once we call the getCatchHere method, we will get an error. This is breaking the Liskov substitution principle. However, this actually could be easily avoided using TypeScript. So if you don't using TypeScript yet, but looking for a reason to use TypeScript, there's one. But it actually goes a little bit more, and one of the tricky things with these principles is they always talk about abstractions. And actually by you following React's do not mutate React state, use set state. So for example, in this example, we say set count instead of count equals count. You are actually following the Liskov substitution principle. It's kind of just a nice little thing to know, I think. The next one, the next principle that we're looking at is the interface segregation principle. So no client should be forced to depend on methods it does not use. This is something that I see quite a bit is actually that often there are components that just take in a class or a DTO, but then only render one or two properties of it. That makes this really hard to use, especially if you use something like TypeScript, because if you get different DTOs, different classes from different sources, but they all have, for example, Pokemon name on it, now you can't use the Pokemon list item because it's expecting a certain class. So better component style would be to just take in the properties that you actually need. And then finally, the dependency inversion principle. And I found a couple of different definitions for this, but to me, the easiest way to think about it is always abstraction over concrete implementation. So one that I see mostly applied, especially in backend languages, is wrapping third-party libraries. So in this case, instead of using Axios as our fetch library throughout our application, instead of writing await axios.get everywhere, we create a util function, which is called API get in this case. And now I can call it. And if I ever decide, hey, I don't want to use Axios anymore, I want to use Fetch or another third-party library. I mean, the browser has Fetch, but you know what I mean. Then we only have one place to change instead of everywhere in our application. So this one we see a lot, but one thing that I don't see enough, I believe, is you can also do this with your third-party components. So for example, if you're using Bootstrap, or here I'm using Chakra, the instead of, if I have a design guide that says, hey, a primary button is blue, instead of just saying button color scheme blue everywhere and have a dependency on Chakra, instead I can create that primary button component that then renders the Chakra button. This in a button case maybe doesn't seem as seems almost overkill, but let's say if you render a select component, or you implement a library like Formic, where if you have form dependencies, this pattern becomes very, very beneficial. And then finally, I just wanted to add that here, because every time I hear discussions about React context, it's usually React context versus Redux or global storage. React context is amazing for dependency injection, which is one way to apply the dependency inversion principle. So in this case, I have a Pokemon storage component that relies on the context that is wrapped around it, and it doesn't know how it's implemented. It just knows it gets Pokemons and it has a delete method. We can use the in-memory provider or the API provider, and that logic then is implemented. So that is cool. So, I mean, worst case scenario, you spend 50 minutes with me here, and if you walk away from this presentation and think like, man, I did not learn anything from this guy, at least you can say, oh, I learned how solid looks like in React. But like I mentioned, those are 5 principles, and there's so much more. There's the dry, do not repeat yourself, but then some people say wet, write everything twice, or then later on, some people, including Kenzie Dodd, for example, mentioned the aha, avoid hasty abstraction. But then there's also single layer of abstraction, Kiss keep it simple, Yagni you aren't gonna need it, and again, all of those are awesome. They are all great rules and great principles, but personally, while I have sat down and looked at a component and apply all of those principles, it just never felt very intuitive or not very practical. I also like there has to be a better way to just get the benefits. And I believe there is. So with that, let me introduce a component that we're going to work through. And that component is going to be the component that we're going to refactor. And as we refactor it, I will introduce the questions. So here's our beautiful, beautiful component. It lists a list of Pokemon types. You can click on them, and then it will list all Pokemons based on that type. And there's a little bit of coloring going on. As you will see, there's 0 CSS in the code because I just wanted to make sure that we really focus on the logic rather than the UI. So the code looks like this. On the top of our component, we see we have a couple of use states. 3 of them are all handling the states of loading types, 3 of them are handling the logic of loading Pokemons, and then we have hooks associated to them to get the data. We also have one which says if the selected type is poison, then there's a warning message. And then on the right picture, we just see the render logic. Okay, let's get to our first question. Is this component testable? Now, this is important before we look further into this. I'm not asking you to test, but you should know how to test. Otherwise, this next step is going to be a little bit more complicated. But you should ask yourself, is this component testable? So if you look again at just the logic, and you have experience with testing, you probably notice like, oh, this is a headache to test. Having so many use states, kind of hard to like spy and mock. You could maybe go a different route and you could mock the use effect. So you could say, well, if Axios get this URL, return this data, but honestly, that's not a lot of fun. And it's a huge headache to write tests for this. So the easiest way to make this testable is pulling the stuff into a hook. Because if you have a hook like that, you can just mock that specific hook. So in this case, I could mock use get types, use get Pokemons by type, and it makes testing very, very easily. Now, I didn't pull out selected type and Pokemon warning. And the reason is, in this case, I saw a clear path on how I can mock or trigger those without having to pull them into a hook. So I knew if I want to get a Pokemon warning, I can trigger a button click for selected type, for example. Now, if I don't feel that it's easy enough to do this testing, or we have a bunch of those internal use states, I would probably pull them also into a hook and just call it use Pokefinder. But again, I'm just going to stick with my question. Is this component testable? Now it is testable. And even better, our component now fits onto one slide. So we made already progress. Now, the second question I will ask myself is, does it read well? And I love this one because, again, it sounds so basic and it's so powerful. And this one really is very much inspired by a single layer of abstraction. But as the question states, I just want you to read the component. So here on the left side, if we start, if we're loading types, show a loading. If there's error types, show error. If there's no types, show an empty message. If there are types, then render a list with list items that have a button that changes state on whether it's selected and with an on-click button, and then render another list. So I'm just going to stop right there. And I kind of wrote it out on the right side. If you notice, there was kind of like this jump in language. We kind of had like if this, then this, if this, then this, if this, then this, and then if blah, 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 which gets really hard to speak. So that's immediately an indication to me that, hey, maybe this is a good time to refactor this part of your application. And I did that right there. So what I did is I pulled out the type list as well as the Pokemon list, because that was like the big unsorted list item, button logic, if it's selected, unselect, like it was just, that's where the jump in language happened. And then we can just do it again. Let's just read it again. So if you start at the top again, if loading, show loading, if error, show error, if type, show type list. If loading Pokemons, then show loading, if error, show error type. So again, maybe when I speak it out loud, maybe not as obvious, but if you kind of read and look at the code, you notice that there's almost like an indent, right? I have all these states related to the type list, and then I do this kind of jump into the Pokemons. So that just makes me think there's even a better way to do it, so it's even easier to read. So that's what I just did here. So I essentially pulled out the type selector and the Pokemon by type selector, and we end up with this code. Now, no matter what we read, if you read the component on the left side, return type selector, a Pokemon warning if there's a warning, and Pokemon by type selector. You see, now all the logic of a component is together. It read nice. If you go over to the type selector, if it's loading types, loading, error types, error, return a type list, Pokemon by type, etc. So it's all there, it's just nicely readable. No more science to it. Sweet. So now we have pretty awesome component, testable component, easily understandable and easily readable component. Now, the last question that I have is this the same? Yeah. And this one will kind of deal with the whole idea of, dry, aha, and wet, etc. So let's look at our three UI components here. And I mean, of course, this kind of applies to pure JavaScript as well, like your functions, etc. But I don't think people have as much issues with that part. So for this, we're just going to focus on the UI portion. So as we look at the code, the first thing I'm going to ask is if is loading types and if is loading Pokemons. That span loading, is that the same thing? And yeah, I think it is. Boolean is true, we're showing a loading. Whether it's a loading indicator, loading, it doesn't matter. It's the same. Error. So this one is interesting because in the top two components, we have a server error, and then we're going to show the server error. And on the bottom one, we have a warning, and it's a client-side warning. Let's keep that in mind, and we'll get back to this later, but for now, and for the sake of the rule, we're just going to say these are the same. And then finally, no Pokemons with this type, no types available. It's an empty state of a list. It's the same thing. Pull it out into component. So we create a new component called loading indicator, a new component called error message, and then one more component called empty list state. And we are done. So to review, the three questions are: is this component testable? Does it read well? Is this the same? And I want you to just keep those three questions in your mind going forward, and that should just trigger you to constantly refactor and write less bad code. Notice that I didn't say you will write the best code and the most perfect code in the world, because I think those three questions will cover 95, 98% of all the code that you will encounter, but there are some special cases where maybe the three questions alone are not enough. And that will kind of bring us into the last part of this presentation, and we are almost done, is a couple of extra tips to kind of help you. And the first one is tip number one, the correct abstraction. I know there's a lot of conversations about this one, and I just want to share how I think about correct abstractions. Remember that warning error component I was talking about a little bit earlier? Maybe when you thought about that error warning component, you maybe had something like this in your mind. You see this, let's say, on Bootstrap, Chakra, and other component libraries where you have this error message, that warning message, an info message, etc., a success message. They're all kind of designed the same. So therefore, there should probably be the same component, right? So you probably created a component something like this. It takes in the type and the message. You could apply some styling to it. There's a slippery road here, because once you kind of go into this, they make this abstraction like this, and the requirements start to change, and you stay married to that abstraction, you end up with some crazy components that take in like 20 different props. It's probably the likelihood of this to happen with a server error or error message is probably low, but you could think about things like, well, on a server error, I want to reload the page, but on a component warning, I want them to just reset the form. So you're going to start putting in an on-click event, and then it just kind of keeps going, right? For more bigger components, I think this is a little bit more tangible. For example, a select component or something like that. There's so many use cases that it becomes very hard to maintain this component, because you have to consider all these effects. So Kenzie Dodd actually tweeted about this, and Chen Creighton called it the apropcalypse, which is pretty neat. And Kenzie Dodd actually has a really awesome talk about kind of a topic and how to apply different patterns to kind of avoid that. But I want you to think about something different. I want you to ask yourself a little bonus questions, and that is, what is less bad? So we identified two options. So we could either create a common component and make them the same, and then we pass in a type to handle the different styling. The other thing we could have done is we could have created a client warning and a server error, two different components, and we just would have written something twice, but some things would have been different. And finally, we could have just left it. And you see, and we will kind of talk about when to refactor, but I think that's the power of constant refactoring is you don't have to be right and you don't have to find the best solution. Most of the time you won't. Because the first one would be the best solution if warning and server errors are being styled the same forever. So when you want more padding on the server and the client error message or warning message, then that's awesome because there's only one place to change it. Now, of course, it also depends if you use CSS and they share the same CSS class, then that could be solved too. But if they have the same logic changes, then again, it makes sense to have one component. If the logic starts to divert quite a bit, then having them two separate components would have been better. But once the logic starts to diverge, you can always pull out this code and make it its own component. But everything would be better than just leaving as it is. Because the issue is if you start having 30 warnings and they're all just span whatever in your code, good luck with trying to make a change that affects all of them. You will have to go through all of them, copy paste the code to every single place. Now, this is all considering very straightforward and simple components. Of course, when you get into like a very advanced components, like an open source library for file uploads, or for a table, or for select, like a little bit more compact ones, at that point, I think you gotta start, or you should look at some of those advanced React patterns, version of control, provider pattern, state reducer, etc. And again, Kenzie Dodd's talk is awesome about this. But until you get to that point, I wouldn't worry about them as much. Because who says you need them to? Maybe having two different components, one React multi-select and one React select is fine. You don't have to create one component that handles all of it. Because those advanced patterns essentially at the end of the day are just for you to create a nice API for the consumer. Cool. So is this the same? Ask yourself, what's the less bad way to go? And I think that will kind of help you to avoid these wrong abstractions. Second tip, architectural decisions. And this one might be a little bit far-fetched, but hear me out. If you are into Redux, if you used React Query or SWR, you may have heard of this, but I kind of came to the same road, if you will. So I used Redux and I had everything in there, and I asked myself, side menu is open and closed, and the list of Pokemon that I just fetched from a database, are those the same things? And I don't think they are, because one is server state and it has two sources of truth, and the other one is UI state and only has one source of truth. So they are fundamentally two different things. Now, I'm not telling you how to solve this problem, but I'm telling you that the question of is this the same helped me to then find potential solutions and clean up my code. You could use two separate stores, one that is purely dealing with server state and one with client state. You could use a library such as SWR and React Query. So give it a try. Maybe you're going to come up with some neat solutions or find potential issues with your code just using those questions. And now to my very last tip around frequency. So to kind of tie it all together, how do you apply this? And I really like the whole red-green refactor idea. You think and plan about what you want to build, you implement the solution, and then you refactor. And when you refactor, you ask yourself the 3 questions and do your changes based on that. Now I think that's very, very, very important because one thing I noticed a lot of my career is that there's a lot of amazing, amazing developers out there. I was joking, like I noticed I met some developers that had every single software book under the sun on their desk and they had no dust on it. They read that book back and forth. They know every anti-pattern, every principle, etc. And some of them are even more genius and they can just apply those principles. As soon as they start writing, they apply these principles. And I saw projects fail because of this, because they started over-engineering the most basic components, abstracting everything away, applying all these rules. So they're following all the right principles, but they're kind of pre-applying all of them. And what that often leads to is A, it's very slow. B, the code ends up changing in some way that they have to keep changing the abstractions that will slow them even more down because they probably made the wrong abstraction given that they only had a small little requirement and tried to predict the future of 12 months of development. And this is kind of to tie this all up, those questions in the refactoring should be just part of you trying to ship code. And just trying to write the best code you can with the time constraints that are given. Because the only bad code is code that has not been shipped. And I don't want you to end up there. Awesome, thank you very much. That's the end of my talk. If you want to check me out, you can check my homepage out, patrickure.ca, my Twitter, Instagram, Medium, and LinkedIn handles. It's Patrick U. I blog about React most of the time, sometimes about .NET. I was going to say .NET Core, but it's not .NET Core anymore. And sometimes I also tweet about life and scuba diving. Thank you so much.